Hi, and welcome to this video on tree preprocessing for high-frequency electromagnetic simulation with Altair HyperMesh. First, we'll cover an overview and what's the motivation in performing this, maybe what's unique about performing tree preprocessing, and then we'll look at a detailed diagram of that, as well as the tips and tricks involved. Tree geometry provides a unique challenge to preprocessing due to the relative size of the members, i.e., the trunk is large compared to the tips of the branches, which come to a fine point. Placing an acceptable mesh, which balances between the quality and quantity of the elements across the entire model, is not a trivial task. While HyperMesh has all the necessary tools to perform this task, it can be time and labor intensive. A solution could be creating a tree toolset extension, which is what I'll be demonstrating here in this video. This helps automate some of the very repetitive tasks and provides a focused and process-oriented toolset, as illustrated here. So I'll focus on the diagram and allow you to take a few moments to read through the tips and tricks, and I'll highlight some of them throughout the video when I'm demonstrating the process. First and most importantly is we're going to be importing a step file or any file that has surface topology. We'll go ahead and organize and scale that to such as organizing to the trunk and the branches into separate components, and also scaling it to being an integer value, i.e. 1 and above. And that helps with a lot of the pre-processing. And at the very end, you could always scale the geometry and mesh to whatever you desire. We're going to go through a couple steps, trimming, validating, such as sealing of the surfaces that we trim, stitching and splitting, so kind of some fine-tuning, and any other final geometry cleanup. Ultimately, what we're looking for is enclosed surfaces of the branches and the tree trunk. Once we have that, we'll use the bounding tool to convert those enclosed surfaces to solids, delete any free surfaces, and then we'll perform a Boolean combine, converting those to a single solid. Then we'll use our mesh controls with our feature-based methods for the body of the tree trunk as well as the branches. If we have some solver-specific quality, we could do some review and optimization, and finally exporting the solver deck. If we're doing it with Altair Fico, it's this .fhm file format. A couple disclaimers and important points is I developed this myself, tested it myself in versions 2022 and 2023. The extension thus has not been officially QA'd, so please use and enhance at your own discretion. And this tree toolset contains only the essential tools of the recommended process. The wealth of the other tools within HyperMesh are also at your disposal, so don't kind of get locked in to just these. So let's go and look at the demonstration. So here I've imported my step geometry, and first I want to go ahead and load my extension. File, Extension Manager, add my extension, and simply want to load the folder which contains the tool. Once we've activated it, it will load into our ribbon, and here we have our tool set. The first tool is our branch trim tool. Is going to function, I should say, be applied to any of the displayed surfaces. So maybe the first thing I'll do is isolate off. Maybe I just want to hide these ones. And I recommend this process to kind of do working from the bottom up, working in kind of branch batches. It ensures that you don't over trim something or become unaware of basically what you're doing, because if you do over trim say a branch such as this one, you could have some free floating branches that you may need to delete. Because this is a custom tool, the trimming operation will permanently delete branches. So let's go ahead and give a measure to get an idea of how much we might want to trim. So we zoom in here. Maybe I could say a 2. Maybe I want to do more. So I think 7 usually worked pretty good for this section. And maybe we'll do 50% trim. And again, this is going to be a global find of the displayed surfaces. So we will have some options. Once it finds the 103, it'll go ahead and highlight them. We have some options to deselect or add, append these. So let me go ahead and shift and deselect that point. I don't want to trim that one necessarily. If I do want to add one, you can hold down Control and add it as well. So let me go ahead and hit trim and delete, and it's going to run through all of those and trim them halfway through along the length. I always recommend saving your model in stages, so you could always go back to that model if you make a mistake or over trim. Where this tool saves you a lot of time, as you might see, is in this trimming operation. Prior, this was done manually trimming hundreds and hundreds of these little branches. So we'll go ahead and hit close here. And what I like to do is personally, for the sake of organization, I like to create new components. Maybe I could title this, trim 7.0. Deselect that. Select my surfaces. Right-click, organize, and move all of those to my new component. Go ahead and hide that, and then turn this back on. But what are we supposed to do then, with these? Now that we've trimmed, we actually have some open, so we zoom in here, we actually have some open surfaces, and that's illustrated in the topology. So let me go back here, and we can see this free edge. So we do have a nice tool next in our tools box called Validate. This is a core tool that helps seal those up. So you could do the sealing of the free edges in batches, or you could do it all in one go at the very end. It's really up to you. But let's just function on this small section just to illustrate the process and for the sake of time. So go ahead and select those, go ahead and hit find. It's going to find those free edges. Go ahead and click on them, and I'm going to say fill, which is this middle icon. Say fix. And it's going to run through and patch all these little bits for me. So again, saving me a lot of time. All right, so once that's done, we can go ahead and exit out of the tool. We might want to clean these up as well. That's not really a part of the toolbox necessarily. That's just general cleaning procedures. I also included the stitch tool if there was any surfaces you may need to clean, merge together, for example. You can also use the stitching tool with its topology function to isolate free edges. So if I just, again, activate the free edges, exit out of the tool, only the red will be highlighted, and those lines, if I change this to a line selection, I can actually select those individual lines, say isolate, and it'll isolate those surfaces. So this is another kind of advanced tip for isolating those. And you could delete those surfaces. Hit S on the keyboard, it'll actually grab those surfaces, and you hit delete. Go back to your stitch tool, turn on your free edges, and turn on your geometry. So that's part of the process. You kind of progressively work through the model, cleaning up the topology of the individual branches, making sure you trim them, and again, always kind of using the measure of the branch thickness. So let's go ahead and move it on, assuming that we've taken a little bit of time to do that. These tools make it much, much faster now. And we'll move on to the bounding. So still in our topology view, I zoom in here, we can see that we have surface topology, is illustrated by the gray. If I go to my bounding tool, and if I click on a surface, if it auto highlights as such, this illustrates an enclosed surface. Thus, I can convert it to a solid. So if I double click it, it'll convert to our transparent green, which is an illustration of solid. So what I can do is go ahead and just select all my surfaces. And if for some reason some don't convert, you'd see them here. Also, if they don't convert, search for surfaces alone and isolate those surfaces. Or you can go solids, hide, and then switch to surface selection. You might have some free-floating surfaces. That's part of the final cleanup. You want to make sure that you delete all those as well. And once you do get your bounding done, we'll move on to our combine. this is pretty important as we want to progressively do this Boolean operation. I would recommend not selecting all of your solids. There's quite a few. I would recommend, selecting them in stages as such. Go ahead and hit combine. And as you select them, you can kind of see how they highlight. And an important feature of this is to not keep a common surface. We really want to merge them. We get this nice trimming operation here, and that's what we want. All of this trimming is done for us automatically. So again, as I had mentioned, kind of do this progressively, working up the model in sections. Again, saving your model as you go along. Not just one single .hm model, again, multiple different files, and name them as you go. So let's go ahead and move on to the last step of meshing. So now that we have enclosed surfaces and everything's booleaned and combined together, we can move on to meshing. I would note this mesh controls can function on solids itself as well as enclosed surfaces. I simply use the bounding and the combine tool to help stitch all the solids together cleanly to give me some clean surfaces. So in mesh controls, I want to create a couple regions, and this just kind of helps with model organization. The first one is going to right click on region from basic, and I want to load in maybe the trunk. So I would go in here and select the individual surfaces, for example, and we'll name this trunk. And again, this is simply for model organization for where we're going to apply our mesh controls. And then we'll do this one, we'll call these branches. And then I can select these surfaces. I'm going to do this very crudely, very quickly, just for the sake of time. But I hope you get the idea here. Because then what I can do is say hide branches, for example, and then go in back to my trunk, maybe zoom in, and just select hold down control and add those additional surfaces, hide, and kind of make my way up the tree. Just takes a few extra minutes. But what it's going to allow me to do is basically focus my attention on the branches versus the trunk with regards to my mesh controls. So let's go to surface mesh, create, and I'm going to do a feature-based mesh. I'm going to do body. I'll go ahead and select my component in the model. This will be the entire tree, and this could be akin to like a global mesh size. Here I'm going to select maybe 500, 100. So it really depends on the values that you want. What's going to be important is that this minimum element size is the average of my local mesh control. So maybe this could be this, call this the tree, and I'm going to create another feature base, and this will be a face type mesh control, and I'll call this branches. This one's a little bit different. I'm actually going to load that region of branches here. And again, if you recall, this needs to be the minimum of my body that helps with the transition between the trunk and then to the branches all the way out to the tips, which will receive this minimum value. And if I need to make any adjustments to this mesh control, it's really easy to do. Simply change these parameters, right click and say mesh. And if I go ahead and do that, and then we'll go ahead and see what the final mesh looks like. All right, so it takes a little bit of time to generate that mesh, but overall, this is what we're looking for. We get that nice refinement around the tip. It's been blunted or trimmed, so we can get at least one element on that tip, and then we transition down progressively to that larger size where we intersect with the trunk, and then we get that larger mesh size. So if I like this mesh, again, you could export it, file export to your particular solver, save it. Something else you can do is actually save this mesh control by exporting it, and you could save it in your file folder, your project folder, and use it for future projects as a reference. So I hope everyone has found this short video helpful, and I hope you find the extension helpful in any of your future tree preprocessing projects. Thank you.